In today's lesson, we are dividing polynomials. We'll start by dividing a polynomial by a monomial. So let's find each quotient. Example 1. If I had the binomial 3x cubed minus 6x, and I want to divide it by 3x, what I'd like for you to do is take each one of the terms in this binomial and divide it by this 3x. So I'm going to rewrite this as two separate fractions. And then simplify each fraction. These 3's cancel. Remember your rule, when you divide like basis, subtract the exponents. 3 minus 1 gives you 2, so that gives you x squared. Well, when I simplify here, these x's cancel. Then 6 divided by 3 gives me 2. So my answer is x squared minus 2. Example 2. If I had 4m to the 5th minus 5m squared minus 12, and I want to divide that by 2m squared. Again, we're going to rewrite this as separate fractions. I've got 3 terms here divided by this monomial, so I'm going to write 3 separate fractions. So I'll take 4m to the 5th, divide it by the 2m squared, minus, take the 5m squared, divide it by the 2m squared, minus, take the 12 and divide it by the 2m squared. Now simplify each fraction. 4 divided by 2 gives us 2. Again, when you divide like basis, subtract the exponents. 5 minus 2 gives me 3, so I'll get m to the 3rd. Well, these are identical, so I can cancel out the m squared, so I get minus 5 halves. Minus, when I come here, I can divide 2 into 12. 2 goes into 12, 6. So I have a 6 in my numerator and a m squared in my denominator. We're going to do one more example like that because I want to make sure you've got it. Example 3. If I had 4x to the 6th plus 3x to the 4th minus 2x to the 2nd, and we're going to divide that by 2x. Again, rewrite this as separate fractions. So I have 4x to the 6th. I'm going to divide it by the 2x. Plus, take my 3x to the 4th, divide it by the 2x. Minus, take the 2x to the 2nd and divide it by 2x. Now simplify each fraction. Again, 2 goes into 4, 2. Subtract the exponents. There's an exponent of 1 here, so 6 minus 1 gives me 5. Here, I can't do any cancellation here, so that 3 halves remains just the way it is. When I subtract 4 minus 1 gives me 3, so I get x to the 3rd. These 2's cancel. 2 minus 1 gives me 1, so I get minus x. So you may see it written like that, or you may see the answer written like this. I could write that 3 halves and put that x cubed level with the fraction bar. Either way would be okay. So we have divided a polynomial by a monomial. Now let's divide a polynomial by a binomial. Example 4. X squared minus 2x minus 15, and I'm dividing it by the binomial x plus 3. Well, this can be factored, so I could, if I want to, factor that numerator. I need 2 numbers I can multiply and get a negative 15, combine and get a negative 3. So that would be a negative 5 and a positive 3. And I can cancel out the x plus 3's. That gives me an answer of x minus 5. Now I'm going to show you a different way to do that in just a few minutes. I'm going to show you a different way, what we call long division. All right, so let's look at example 5. If I had the trinomial, I'm going to just do it like this. X squared plus 11x plus 24. And I want to divide it by x plus 8. Two numbers I can multiply and get 24. Combine and get 11. Those numbers are a positive 3 and a positive 8. And again, I can cancel out that, and I'm left with x plus 3. Okay? So you will be able to do that sometimes, but not all of the time. So we're going to do what we call long division. So we're going to find the quotient by using long division. Now I'm going to put a basic math problem over here just to refresh your memory. If you recall, when you were in elementary school and you did your division, you divided 6 into that 35, you put a number up there in your quotient, okay? So you put a 5. Once you put something in your quotient, you multiply. After you multiply, you subtract, and you brought down the next digit, and then you were ready to divide again. So we're going to use that same concept with these polynomials. The only difference is, here I have digits, but in algebra, I have terms. Now remember, this is your dividend, that's your divisor. So I'm about to set this up for long division. This is going to be my divisor, and this is my dividend. Now I'm going to take the first term in my dividend and divide it by the first term in my divisor. So I'm asking myself, x squared divided by x gives you what? Or x times what would give you x squared? It would be an x, so I'm going to put an x up here in my quotient. Again, when you over here, once you put something in your quotient, you multiply. So I'm going to multiply this x times everything here in my divisor. X times x gives me x squared. So when you start multiplying, if these are not identical, then you've done something wrong. X times 7 gives me a positive 7x. Well, in your regular division, after you multiplied, you had to subtract, so I'm about to subtract. Any number minus itself is 0. 3x minus 7x is a negative 4x, and I'm going to bring down my next term, and I'm ready to divide again. Over here, you had to divide again, okay? So now I'm going to ask myself, x times what would give me a negative 4x? That would be a negative 4, so I'm going to put minus 4 up here. Now multiply negative 4 times your entire divisor. A negative 4 times x gives me a negative 4x, and a negative 4 times a positive 7 is a negative 28, and now I'm ready to subtract, and any number minus itself will give you 0. That is called long division. Example 7. I'm going to take x plus 5 and divide it into 3x squared plus 9x minus 15. Again, you start by taking the first term in your divisor, divide in the first term of your dividend. Ask yourself, x times what will give me 3x squared, and that would be a 3x. Put it in your quotient. Make sure you put it in the correct place. Now multiply what you have in your quotient times your entire divisor. 3x times x is 3x squared. When you start multiplying, if these are not identical, remember you've done something wrong. 3x times 5 gives me a positive 15x. And I bet you can guess where students make their first mistake on subtraction. We're about to subtract. Any number minus itself is 0. 9x minus 15x gives me a negative 6x. Bring down your next term. You're ready to start the process over again. X times what would give me a negative 6x? It would be a negative 6, so I'll put minus 6. Now multiply negative 6 times your entire divisor. A negative 6 times x is a negative 6x. A negative 6 times 5 is a negative 30. We're ready to subtract. Well, any number minus itself is 0, but a negative 15 minus a negative 30 gives me a positive 15. So I have a remainder. So in elementary school, remember you took the remainder, put it over the divisor. That 15 is positive, so I'm going to put plus 15 over my divisor of x plus 5. Example 8. Let's take n minus 2, and let's divide it into n squared plus 6n plus 2. Again, take the first term in your divisor, divide it into the first term of your dividend. N times what gives me n squared? N. Multiply what you have in your quotient times your entire divisor. N times n gives me n squared. N times a negative 2 gives me a negative 2n. After I multiply, I subtract. Again, any number minus itself is 0. 6n minus a negative 2n is 8n. Bring down your next term. Start the process over again. N times what gives you 8n? It would be a positive 8, so I'll put plus 8. Multiply. 8 times n gives me 8n. 8 times a negative 2 is a negative 16. I'm ready to subtract. Any number minus itself is 0. 2 minus a negative 16 is a positive 18. So I would put plus 18 over my divisor of n minus 2. Example 9. On example 9, we have the trinomial 2x cubed plus 2x squared minus 4 divided by the binomial x minus 1. My divisor is x minus 1. Now if you notice, I have an x to the third, an x to the second, but I don't have an x to the first. So we're going to insert what we call zeros. If you add a 0 to something, that doesn't take away from anything, because if I take 0 and add 4 to it, I still get 4, okay? So if I insert zeros, and the purpose of inserting a 0 is for you to have some place to put your terms when you multiply. That does not take away from anything, okay? So now we're ready to divide. X times what gives me 2x cubed? I would have a 2x squared. Multiply. 2x squared times x gives me 2x cubed. And 2x cubed times 2x squared times a negative 1 is a negative 2x squared. Well, I'm ready to subtract. Okay? When I subtract, any number minus itself gives me 0. 2x squared minus a negative 2x squared gives me a 4x squared, and I bring down the next term. Now you're going to see why it's important to have that 0x. X times what gives me 4x squared? That would be a positive 4x. When I multiply, 4x times x gives me 4x squared. Then 4x times a negative 1 gives me a negative 4x. I'm ready to subtract. Any number minus itself is 0. 0x minus a negative 4x is a positive 4x. Bring down the next term. Ask yourself, x times what would give me 4x? That would be a positive 4. Multiply 4 times x gives me 4x. And 4 times a negative 1 gives me a negative 4. And any number minus itself gives me 0. One last example. Number 10. If I had x to the 4th plus 2x cubed plus 6x minus 10, and I want to divide that by x plus 2. Again, I have a missing term in this problem. My divisor is x plus 2. I have an x to the 4th plus 2x cubed. I do not have an x to the 2nd, so I'm going to insert a 0. And let's divide. X times what gives me x to the 4th? That would be x to the 3rd. Multiply. X to the 3rd times x is x to the 4th. X to the 3rd times 2 gives me 2x cubed. When I subtract, any number minus itself is 0. Any number minus itself is 0. I'm just going to bring down the 6x minus 10. X times what gives me 6x? It would be a positive 6. 6 times x gives me 6x. 6 times 2 gives me 12. When I subtract, any number minus itself is 0. Negative 10 minus 12 is a negative 22. That 22 is negative, so I'll put minus 22 over x plus 2.